Welcome students to our today's lesson. Today we are going to study the properties of soils, and we have got two major classes. According to the properties of soils, we have the physical properties and then we have the chemical properties. So under physical properties, so physical means in fact what you can be able to see. So that is the definition of the word physical, what you are able to see. And now when it comes to the physical properties of soils, we are going to study about those properties that you are able to see in soils with your eyes. So, under soils, we have major classes under the physical properties of soils. We are going to straight away go to the classes. And the first one is the soil separates and the texture. The second one is the structure of the soil. The other one is weight and soil density. Then the third one is porosity of soil. We have permeability of soil. We have soil color, as you can see from what I'm pointing. Just look at whatever I'm pointing. We have temperature of soil, and the last one is soil plasticity, compressibility, and erodibility. So these are the different classes of soils, or the different classifications under the physical properties of soils. And we are going to see the first property under the physical properties. So the first one is the soil separates, and the major part of soils is the mineral components, soil, which is the soil mineralogy. And the mineral fraction of soil consists of particles of various sizes. According to their size, soil particles are grouped in the following types. So we normally classify soil in terms of their separates in the following groups. We have the coarse particles, and the soils with coarse particles, they have a diameter of 2 millimeters, 2 millimeters diameter. And number B, which are the coarse sands, they have a diameter of 2 to 0.2 millimeters. The other one is we have the fine sands, whereby they have a diameter of 0.2 to 0.02 millimeters diameter, as you can see from whatever I'm pointing. We have the silts. Just look at whatever I'm pointing here. We have the silts, whereby they have a diameter of 0.02 to 0.002 millimeter diameter. We have clay soils, whereby they have a diameter which is below 0.002 diameter. And the particle sizes of above groups are suggested by the International Society of Soil Science. So these particles have been, all these sizes of particles according to the separates, we have this body, which is the International Society of Soil Science. It is the one which has come up with these classifications based on the soil separates. And in India, for example, this international system of particle classification is commonly followed. So in India, they really follow this much. And the particle types are generally called soil separates or soil fractions. The amount of soil separates is determined by a process known as chemical analysis. And in this process, soil sample is crushed and screened through 2 millimeter round hole sieve. And the screened soil is then homogeneously dispersed in water and allowed to settle. In dispersion, particles of largest dimensions will settle first, and those with smaller dimensions will settle afterwards. Individual soil particles are identified on the basis of their respective diameter ranges. Soil separates, we have the sand, silt, and clay, differ not only in their sizes but also in their bearing on some of the important factors affecting plant growth, such as soil aeration, workability, movement, and availability of water and nutrients. So I want us to go to the different characteristics, or the characteristics of soil separates. And we are going to see the first one. We are going to look at sand. We see some of the characteristics that a sand contains, and we say that sand has got the largest particles. And under sand, any loose and friable mineral particles ranging from 0.03 to 0.02 millimeter diameter are called sands. So these are the ones which have the biggest diameter. And the sand particles can be seen by an unaided eye. So you can be able to see the sand particles simply because the particles are big. And these particles, although inactive, constitute the framework of the soil, and they play less important role in physiochemical activities. When coated with clay, these sand particles play an active role in chemical reactions, and the sands increase the size of pore spaces between soil particles and thus facilitate the movement of air and water in the soil. They facilitate easy movement of air and water in the soil simply because the particles of sand, they are large and they are able to allow water and air to move freely in between the particles of the soil. And let's go to the second, which is the silt. And the silt, the soil minerals particles ranging from 0.02 to 0.002 millimeter diameters are called the silt. So this is the second classification, which has smaller particles in comparison to the sand. And this is an intermediate size between sand and clay. Silt, when wet, feels plastic, but in dry state feels like flour, or we call it the vacuum pounder. And the coarse silt shows little physiochemical activities, but finer grains play important role in some chemical processes. Silt soil has got larger exposed surface area than the sandy soil, and it is because the particles of silt are a little bit small in comparison to those ones of the sand, like we said. Silty soils contain sufficient quantities of nutrients, both organic and inorganic. So in comparison to the level of nutrients that are contained in those soils in between the sand and the silt, so silt has got more nutrients in comparison to the sand. And that is why they are very fertile masses. That's the reason as to why silt is usually fertile. And the soils rich in silt possesses high water holding capacity also. Such soils are good for agriculture. So silt is the best soil that is best in agriculture because it has most of the nutrients in comparison to sand. So let's stop there, students. Let's meet in our next lesson.